Welcome to the Hello World with Extreme Scalability screencast for Gigaspace's ZAP. First, we'd like to go through the types of components a typical application will have, along with giving them common names that the example projects and Maven archetypes use. Then, we'll step through running the Hello World example application in Eclipse and follow up with running it in a full ZAP instance. Here, we have all the pieces displayed but not labeled. Data comes in from some source and then goes into the grid where it's processed. The domain module is normally held in a common module, which can also hold other common classes for other modules, different services, things like that. Normally, however, common is objects that are really across the entire application. The feeder module represents an external stimulus that causes data to go into the space. This could be anything, an external Swing application, a web application, even other processing modules. In the example applications, it's normally a command line application that connects to a space and writes data in. The processor module just generates a processing unit, a point of scalability for the space. A processing unit lives in the space but can be distributed right along with data, which is part of where scalability happens, because most grids can scale processing or data, but that means the choke point for scalability is data acquisition or processing power acquisition, whereas ZAP scales both at once. A processing unit doesn't normally have to wait to get data because it's localized to the processing unit itself. Our next step is to take a look at the Hello World application, which demonstrates all three of these pieces operating together. So now we have Eclipse open. Let's import the Hello World project, which is in, hold on just a second, we import existing projects. It is in the Gigaspace's home directory, examples, Hello World. And what we'll see is three components, our common, feeder, and processor modules, just as we already saw. So let's go ahead and import all of those in. And what you'll see is they'll actually open up with red, so it's a good web application because it has red all in it. These are because the build uses an environment variable called GSHome, which we haven't defined. So let's go ahead and define that. And it will point to our Gigaspace's installation directory, which we just loaded all of our stuff from. So we go to Tools, Gigaspaces. It will then rebuild, and everything will, all of our red X's disappear. So we're no longer a good web application, but we do compile. So let's take a look at our data, the message object. It's really simple. It's just a POJO. It has one space-related annotation, the space routing annotation, which is right here. This tells the system how it can partition data in the grid. Normally you wouldn't use an explicit ID like this, but normally you wouldn't use a distributed computing platform to say hello either. So you can see here we just have an info field and an ID. It's a very simple object. It's serializable, but it doesn't have to be. It can be really anything. So let's look at our feeder application. Our feeder application is a little bit more complicated. First off, we invoke it with a command line argument. Then it will create the feeder and then create 1,000 elements and then call read result. So this is how we can declaratively acquire the space given a URL. But normally you don't do this. You'll use Spring to get your space, but we'll show that in the next section. Feed is very simple. All it does is it takes the number of messages to create, iterates through it, then creates a message for each one and writes it into the space. Read results a little bit more complicated. It creates a template, sets the world, sets the info to match something that's been completed, gets it from the space and writes it out. Then it waits for a little bit just to give the processor a chance to catch up, and because we're only going to have one thread here in this case, so it takes a little bit to process everything. Then it counts them out and writes them into standard out or our logging, wherever our logger configuration points. So the processor is a little bit more complicated. Not much, but it's a Spring application in this case. It has a Spring configuration. with a couple of custom namespaces defined with a couple of tags. The three tags that we will see in almost every application is the core space tag, which defines what is an IJ space. If we look back at feeder, as soon as Eclipse does its job, you'll see here the IJ space. That space tag is equivalent to this tag right here. So then we have a transaction manager, which refers back to the space. Then we declare a gigaspace, which is an extended API on top of the standard IJ space. Again, if we're looking at our equivalent, this right here is equivalent to this tag. This means that this is a Spring reference we can inject anywhere or supply to anything. In this application, we won't really need it because the event container will do it for us, which is actually very convenient. This is just an ordinary Java bean. We should probably take a look at it so that you can see how easy it is to define this stuff. We have one annotation that's related to the space in this, which is space data event. This tells the, we'll get into that in just a second actually. Let's look at the message handling method first. This is an ordinary method. There's nothing special here. It takes an argument, then it returns something. It returns the same type. So what it does, it takes this argument, sets the info, and then returns it. This is eminently testable. This is incredibly testable, insanely great, actually, because it means all your test has to do is create a processor, then create a message, call this processing method, and check the result. There's nothing to it. You don't even have to return the same type. You could return an array of messages. You could return a completely different data type. You could return message handler or message response, anything. When you look back at when the space actually calls this, what it will do is it will actually pull this message from the space, then call this method, and when it will return, whatever you return here will get stored into the space. So you can see here we aren't doing any space-specific stuff, but this will actually modify messages in place in the space, just like we'd want it to happen. The way that we declare that is through a polling container, which uses polling semantics. It's not actually a poll, but it uses polling semantics. What it will do is it will look for anything that matches this template. The type is message. Anything that has an info field that has hello with a space after it. Then it will pass it to whatever event listener we have here, which is our hello processor reference up here. Believe it or not, we've just done a complete workflow. Everything works here, just almost by magic, although it's clearly technology and not magic. So let's see this thing running. First, we'll run the processor. The projects, whenever they come in, come with two different run configurations: the hello processor and hello feeder. The hello processor uses a class that's called the integrated processing unit container. This will load that Spring configuration for us, and then create all of our services so other things can connect to it. So let's go ahead and run this puppy. You can see here we're running everything. If we look at our log messages, you'll see here the processor is instantiated and waiting for the message feed. This message comes from this line right here whenever we instantiate the processor. So our next task is to run the feeder. So we go back to our run configurations and run the hello feeder. This is just an ordinary, we just invoke the main class. Our argument is the processor space. We're telling it here the Jenny protocol, any host, any container with a space name of processor space, which will run where we want it to run. It'll connect to the integrated container we just created. So let's go ahead and run this. This is actually the processor window. Here we're going back to the hello world reader, the window, the console window, but you can see that it wrote 1,000 messages, printed one of them out, and then echoed there were 1,000 messages in the space. So if we go back, let's eliminate this window and go back to the processor window, and you can see here we have all of our objects coming through. They're not ordered. This is actually a good thing. Order means that you have a sequential set of processes, which is fundamentally difficult to scale. By using a lack of order, what we end up doing is we can distribute this to 1,000 different processors if we wanted to, and we get linear scaling if we or near linear scaling, which is what we want to have happen. This is incredibly powerful and a good design. So what we've seen is running our application in Eclipse. We've seen our 3 modules displayed or created. We've seen it running inside of Eclipse in an integrated container. Next, we'll run it in the full Gigaspaces Zap container, an external container. Let's go ahead and kill this stuff off, and we'll see. Let's go ahead and go to our integrated container, our standard container, rather. So here we have our GS UI open. It shows that we have a GS agent running on a local host. This is my laptop. We see 2 GSCs and 1 GSM, 1 lookup service, which is the standard default configuration. We can see our logs down here for all of the different things. So what we do next is we go ahead and we're about to go ahead and deploy our application. But first we need to build it. So what we do is we go to the Hello World directory and then do a build dist, which we'll call ant, and then build our processing unit for us. It will put it in the hello processor, the processor processing unit hello processor.jar file. So then we come over here and we deploy a processing unit. You can see here I've actually deployed this before, so it's still in cache. Now here's our actual thing that we just built. Select that. We'll use the default configuration. We don't have to do anything special there. And to deploy it. So now while we're waiting for that to go through, it's actually going to the GSM and then going through to a GSC. We can see that it got deployed to GSC2. We can see the log here. Here's our processor instantiation message that we saw from Eclipse. GSC1 has nothing going to it. The GSM, you can see how it's gone through the whole allocation process. Now we need to go ahead and run the actual feeder. So let's go back to our Hello World. We actually still have a convenient script for that. We have build run feeder. Now you notice we're going to go ahead and we've got GSC2 in this window, so we'll be able to see it operating whenever we're running the application. So now it builds everything, and then it will call the run feeder with with the default configuration, which is very like the Eclipse configuration. And you can see that our processing is exactly like it was before. We have all of our information here. Lots of magic there, I suppose. And our output here is exactly like it was in Eclipse. We've got an info message from Java logging. The key here is that if we look over here, this is all on the same machine. But if we weren't running on this host, we'd still be able to use this UI to see the logging messages. As long as we're using Java logging, it's very easy for us to see what's going on in the entire system at one time. So now we've seen the 3 basic component types for a scalable application in Gigaspaces. This is part of the Gigaspaces distribution in the examples Hello World directory. Take a look. I think you'll find it remarkably simple to set up a scalable, remarkable, reliable, resilient, one person described it as uncrashalizable, a term that I completely love, application. Hope you've enjoyed this, and thank you very much.